Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Khair Nizam. I'm from the ALG section 2. So for today, I will present about our assignment project, the AKC 3543 microprocessor. So the topic we choose for this project, assignment project, is smart fence. In these slides, we have introduction, problem statement, result, conclusion, and the last part is recommendation. So for right now, we'll explain about our team members. In our group, we have 4 members. The first member is me, Muhammad Ashraf bin Kurizam, and the second member is Muhammad Ali Farhan. The third member is Muhammad Arif bin Suhaimi, and the last person is Muhammad Azam bin Muhammad Rozi. So for today, I will present about introduction for this project. So the introduction for smart fans. This assignment project, we call that fan control system that was designed around the microprocessor 68000. So the primary objective of this project is to utilize the 68000 microprocessor components that will create a program that controls the speeds of fans. In this fan control system, we have a 7 segments which is employed to regulate the fan speeds. And our projects, the aims for this project is to facilitate learning of assembly language, program design, execution, and simulation based on the provided manual. So the core focus for this project is what? Is on the stimulating the software and executing the hardware based on the manual guidelines. The process involves a step-by-step approach, learning assembly language, designing a program, executing the program, and lastly, simulating the hardware. So this project not only serve as a learning experience in microprocessor programming, but also provide practical insight into hardware-software integration. The transition from a blender machine to a fan control system underscore the versatility of the microprocessor 68000, showcasing its applicability in work. So the second topic I will present about problem statement for this topic. So the first problem statement is consumer often express dissatisfaction with traditional fans, citing problems such as inconsistent airflow or difficulty in adjusting the speed on their preference. So the second problem statement is the project of this report is to analyze and address the challenges in designing and implementing a smart fan system that enhance user to be more comfort, energy efficiency, and convenience.
Yes, Assalamualaikum. My name is Muhammad Ali Farhan Muhammad Nazri. Now I will continue our presentation about our project. So this is the coding that we use to make the smart fans program. So for the first, this is the declaration part, which is we declare the address to use in the program, and the switch we declare for 00012 and for LED 00010. And this the declaration of the 7 segments, which is 0, 2, 4, 6, 8, A, C, and E. Okay, then this is the initial declaration of initial condition, which is we use the initial condition to store the condition into the switch. Okay, so this now we move to the main loop and decision making part. Okay, so this the decision making parts that we use D1 and D0 LED and compare switch D1 if switch D1 we compare to on, switch D2 for speed 1, switch D3 switch 3 for speed 2, switch 4 for speed 3, and switch 5 to off. And then the bra meant to repeat the programs. Okay, then this is for on subroutine, not startup. So for the first D0 will to LED. So D0 after we run the program, the LED for D0 will open, and if we start the program, the switch one, the zero LED will open. So this is the segment that we use to declare the display. So for we use segments for 0 to make a dash 7F for 0, so 3F for 0, 37 for N, and dash. So this will display dash on dash after we on the switch one. And then for the speed one, for the speed one routine, so we use rotate to right, that the LED will rotate, will blind rotate from left to the right, slow. So this we use the same segment to declare the display speed one. So needs 0 or do not have an SPEED 0 1, and then the program will repeat. And next, speed 2 also we use the rotate the blind, the LED blind from left to the right, and it will be fast. And it's a declaration for speed 2 SPEED 2 for the server segment. Then for the subroutine speed 3, also we use rotate from left to the right, ROR. So this will be faster, and this the server segment display SPEED3, and the program will repeat again. And then so these are the subroutine for off, not stop. Okay, so this the blind and the blink LED. So the LED will blink for from right, left, right, left. And then this is the same segment that show the display of dash of O F F dash, and the program will repeat. Okay, then this is the delay subroutine part that we use to manipulate the data for speed. So for the uh, so this is the speed of the rotation blink at the stop. So we use 2000 20,000, and then subroutine, and then this will be wait. Okay, then the uh movement of LED at the slow, fast, and faster that we used to that we use at the speed 1, speed 2, and speed 3. So we use sub.w. Okay, so for the first we use 10,000, 10,000, and 5,000, and then 3,000 for slow, fast, and faster for the speed 1, speed 2, speed 3. So if we use sub, so if the uh, if the value getting small, getting small, so the LED blind transfer will be more faster. And then the last one is of with the initial calculation 1,000. So that's all from me. And now I will to I will to pass to the next presenter, which is Muhammad Azam.
Okay, my name is Mama Azam Mama Azif. I will present about hardware from the coding and the title of my project is smartphone. So I will run first. Okay, first I press the button 30. then it will display is on. Is on. And the LED has one light will light up on the right side without blinking. Then I will press the switch button 1 for speed 1. Flash in fast state, the LED light flash from the left to right. Next, I will push switch button 2 to on the speed 2. And watch blink faster than speed 1. Next, if I want more speed, so I press button switch 3. So that was display speed 3 and LED was blink fastest than speed 2 and 1. Lastly, to get smartphone stop, so I press switch button 4 to stop operation. So that display stop. Then LED will blink alternately. Okay. That's all from Pizza Hardware. Okay. It is for flowchart. So we have start, input variable speed, and for input variable speed we have 3, 1, 2, 3. Okay. If we on speed 1, the output will display speed 1. Then for the speed 2, we turn on speed 2 will display speed 2. And for the speed 2, for faster, for the speed 1 is fast. So if we want more speed, we turn on the speed 3. And speed 3 is fastest than speed 1 and speed 2. So after that, for the lastly is N. N is stop. That's all for me. Present about Pizza Hardware and flowchart. I will give for next member to my friend is Mama Arif. Okay, thank you.
My name is Muhammad Arif bin Swaini. So, as the last presenter, so today I'm going to talk about the conclusion and recommendation. So, our project is smart fence. So, using data transfer instruction, we ought to be able to create a basic assembly program for MC68K CPU, and we can run the project on the MC60XK software. So the goal of this initiative is to provide global solution to the challenge faced by individuals. So our program can be used for daily use as well. For example, it can be used to make fans, food blender, and other projects related to speed. It's mean like if we want to control speed, we can use the coding or the program for the same coding for the same project. So next, if our program is used to create final projects, then with the switch button and close button and the speed we want. For example, the first speed is normal. So in this project we have 3 speed. So the first speed is normal, and second is fast, and the third is getting faster. Which mean it's getting faster if the value increase up. Okay, so next, it also works like a friends project just by pressing the on button, close button, and the fast button. Our problem will be solved easily without any effort, and saving energy, time, and more. So next, recommendation. So based on our project, there are 2 recommendations. So firstly, energy efficient operation. So implement energy saving features such as timer, sleep mode, power consumption monitoring to ensure the smart fans operate efficiently and minimize energy usage. So the second recommendation is user-friendly interface. Design a intuitive and user-friendly interface. Either a mobile apps or a physical control panel that allow user to easily adjust fan setting, create personalized schedule, and view energy consumption data. So next, this is the example of the picture. So the fans and the device that control the fans. So we put the coding inside there, so we can control by using this. Okay, so that's all from group 11 and from me. Thank you.